Bismillahirrahmanirrahim and Assalamu alaikum students. I hope all of you are good and doing well at home. So students, if you remember in the previous lecture you have learned about theorem number 5, and in this lecture we are going to start our theorem number 6. Okay, so in this lecture you will going to learn about theorem number 6. So overall this is your lecture number 34 and I am your math teacher Miss Falak. Before starting theorem number 6, I want to tell you one thing, that this theorem number 6 belongs to chapter number 12, demonstrative geometry. Okay, so when you will open your when you will open your math book, so chapter number 12, demonstrative geometry, you can see theorem number 6 there. Students, as you all know that before starting any theorem, I always explain some basic concept that you should recall before learning any new theorem, right? So what we are going to review before starting the theorem is about triangle, because our upcoming theorem is going to be about triangles. Okay, so let's quickly revise what are triangle. What is a triangle? A triangle is basically a figure bounded by three straight lines. Okay, what is a triangle? It is a figure that is bounded means joined. Okay, joined with three straight lines. The lines should be joined with each other. Okay, lines should be joined with each other. As you can see here, there this is a triangle. So why, as you can see, this is a triangle. So why this is a triangle? Because it's a figure that is bounded with three straight lines. If you talk about this one, so this is the figure which is bounded by approximately 1 2 3 4 5 lines. So this is not the triangle. So in triangle you must have three straight lines and that should be bounded with each other. After that, it has six elements. Okay, now six elements, out of which three are angles and three are sides. Now let's consider this one. This is basically a triangle. As you can see, why we are saying that's a triangle, because it is bounded by three straight lines. Okay, and it has six elements. Now what are those six elements? Number one, this one, three angles. Okay, A, B and C. Okay, so this is A, this is angle B, and this is angle C. So in every triangle there are only three angles, not more than three and not less than three. Okay, they must have, any triangle must have three angles as well as three sides. Now what are sides here? This one, this is side number one. Okay, this is side number two and this is side number three. So there are three sides in every triangle. This is side A, which side AB, this is side BC, and this is side AC, or you can say CA. So in a triangle always you have three angles and three sides, right? After that, the new topic that I'm going to explain here is one-to-one correspondence between true triangles. Okay, one-to-one correspondence you have learned it about in class 6 as well as in class 7. But obviously, one-to-one correspondence between two triangles is a new topic. Okay, so what does it mean by one-to-one correspondence between two triangles? Now let's consider this triangle. This is a triangle with the name A, B, and C. Okay, and this is another triangle which is P, Q, or although according to name. Okay, if I'm going to check according to their name, so the name of this triangle is A, B, C. This is triangle P, Q, R. So according to name, although they are different triangles, but you can establish a one-to-one correspondence between these two triangles. Now how? What does it mean? Look at here. Every triangle, any triangle in the world has three vertices. Three vertices means the joining point where the lines will meet with each other. So here this is the vertex number one, this is the vertex number two, and this is vertex number three. So in every triangle you have three vertices and three sides. Okay, three vertices and three sides. This is side AB, BC, and CA. Similarly, PQ, QR, and PR. So in every triangle you have three vertices and three sides. So it is always possible, this is very important, it is always possible to establish a one-to-one correspondence between the sides. Okay, between the sides, angles, and vertices of two triangles. Now what does it mean? Just suppose before that, you should know how will you represent the correspondence. So symbol, this one, okay, this symbol is used for one-to-one correspondence, that is one-to-one correspondence. So the symbol for a correspondence is this line, this symbol, okay. Now look at here, what does it mean? The statement ABC, triangle ABC corresponding to triangle PQR. What is the statement here? Triangle ABC, 1 minute. Okay, now what is the statement here? Triangle ABC, okay, is this triangle is corresponding to triangle PQR. Now what does it mean, Kate, if they are corresponding? Means the question is still in your mind that what does it mean that they are corresponding to each other? It means that A, point A, okay, I'm talking about point A, or you can say vertex A. Point A is corresponding to P, just like here. This A will be corresponding to this P. 1 minute. Okay, now this A, okay, this A is corresponding to this P, okay, P, point A is correspondence to P. Hence B, okay, this point B will be corresponding to Q, and then C, okay, point C will be corresponding to R. Okay, so it will be said one-to-one correspondence. Understand? So in a triangle, you can establish a correspondence. Okay. Similarly, you can also establish correspondence between the angles. How? Look at here. Angle A is correspondence to angle P. Which is angle A? This one. So you will say that this angle A, the corresponding angle of A will be this P. Okay, the corresponding angle of B will be Q. As you can see here, B is corresponding to angle Q. Similarly, the corresponding angle of C will be angle R, this one. Okay, so what does it mean by triangle ABC and triangle PQR corresponding? Means their vertex, their angles and their sides are always congruent. Just suppose if here I have explained about the vertex and angles. Now the next one is about the sides. Now what are the sides here? Similarly, AB, side AB, line segment AB. Here is the line segment AB. Okay, the corresponding side of AB will be this PQ. Okay, so AB will be corresponding to PQ. Similarly, the corresponding side of BC will be QR, and the corresponding side of AC will be PR. Okay, so one-to-one correspondence means every triangle has three angles, three sides and three vertices. So it is always possible that you can establish a one-to-one correspondence between the triangles. Right, now move on to the next one. Next is the congruence of triangle. Okay, you know what does it mean, congruence? Congruence means equal, right? So congruence of triangles means what? Now again consider these two triangles. This is triangle ABC and this is triangle PQR. Okay, this is triangle ABC and this is triangle PQR. So what does it mean by congruence of triangles? Two triangles, again here we are talking about the two triangles. Two triangles are said to be congruent. When you will say that the triangles are congruent, if their corresponding angles. Now what are corresponding angles here? Corresponding angle means the corresponding angle A and P, okay, the corresponding angle P and Q, and the corresponding angle C and R. So they are corresponding angles and sides, corresponding sides. Now what are corresponding sides? This AB and PQ are corresponding to each other. BC and QR are corresponding to each other. Similarly, AC and PR are corresponding to each other. So when you will say that the two angles are congruent, when their corresponding angles and sides are also congruent. Okay, if their corresponding angles and sides are congruent, so you will say that the triangle is, the given triangles are congruent. Congruent means equal. So in triangle ABC, if the triangle ABC is corresponding to triangle PQR, so what does it mean? It means angle A is congruent to angle P, as I have explained it earlier. Okay, what does it mean? Angle A is congruent to P. B will be congruent to Q. Congruent means equal. B will be congruent to Q. Similarly, C will be congruent to R. Okay. And also their sides will also congruent. Just suppose AB, side AB, this is side AB. So side AB will be congruent to side PQ. So then side BC will be congruent to side QR. Then side AC will be congruent to side PR. Okay, so when you will say that the triangles are congruent when their corresponding angles and sides are also congruent. So you will say that two triangles are congruent to each other when the angles and sides are also congruent. Okay, so this is called congruence of triangle. Now let's look at this one. What is this? Let's quickly, not quickly, but please carefully listen to this. If in a given correspondence of two triangles, means if the triangles are correspondence, okay, we are talking about when the triangles are correspondence, two sides, okay, and I'm talking about two sides, and the included angle of one triangle are congruent to the corresponding two sides and the include angle of the other, the triangles are congruent. Little bit confusing, yes, I can understand this is little bit confusing, but before that I'm going to explain it with the help of this figure. Now look at here, again I'm explaining. If in a given correspondence triangle, as you can see here, ABC is corresponding to triangle PQR. Okay, if the two sides, okay, now what are two sides? Just suppose this is side AB and this is side BC. We are talking about these two sides. Okay, sides AB and sides BC. Okay, and the include angle. Okay, now what I mean by the include angle? What will be the include angle? This is side AB and this is side BC. So the include angle will be this angle B. Okay, the include angle will be this angle B to the corresponding two sides. Okay, now the corresponding side kya hogi AB ki? The corresponding side of AB will be PQ and the corresponding side of BC will be this QR, and their include angle will be this Q. Okay, so what you will say that the triangles are congruent means when you will say that triangles are congruent, when the two sides and the include angle of one triangle is corresponding to the two sides and include angle of the other angle. So you will say that these two triangles are congruent. Okay, and this thing is called as side angle side postulate. Side angle side postulate means, 1 minute, side angle side postulate means side, okay, then angle, and then side postulate. Side angle side postulate. So according to side angle side postulate, if triangle ABC is congruent to corresponding to triangle PQR, so AB will be corresponding to PQ, this AB will be corresponding to PQ, then B will be corresponding to Q, okay, and the side BC will be corresponding to side QR. Okay, two sides and two angles are congruent to each other. So you will say that the given triangle is corresponding to each other. When you will say that the triangle is congruent to each other, basically this is a symbol of congruent. Okay, this is a symbol of congruent and this is a symbol of correspondence. Okay, if you have any triangles that are correspondence to each other in such a way that their sides and the included angle are also congruent, so you will say that the given triangles are congruent to each other. So this is called side angle side postulate. Understand? Now, I hope all the things are clear to you because I'm going to start the theorem here. Okay. Now, this is your theorem number 6. Now, what is your theorem number 6? Look at here. If two sides, okay, two sides of a triangle are congruent, two sides of a triangle are congruent, then the opposite angles to them are also congruent. Now, what does it mean? Two sides. Okay, now what are those two sides? This one, side AB and side AC. if these two sides are congruent, okay, so their opposite angles. Now what are their opposite angle? This angle B and this angle C. So if the sides are congruent, so angles will also congruent to each other. This is the statement of theorem number 6. Now what you have to do in this statement, you have to identify which is given to you, what the things that are given in the theorem, and what you have to prove. Okay, the given thing is basically two sides. Okay, in triangle ABC, they are saying that side AB, this is side AB, this side AB is congruent to side AC. Okay, what is it? Theorem number 3, what is given in theorem number 6 is that in triangle ABC, side AB is congruent to side AC, and they are saying if the sides are congruent, so their opposite angles will also congruent. Now what are their opposite angles? Angle B and angle C. So what you have to prove, if the sides are congruent, so their vertical and opposite angles will also congruent. Now what are their opposite angles? This angle B and this angle C. So you have to prove that angle B is congruent to angle C. You have to prove this thing, and this is given to you that the sides are congruent. Okay, so based on the previous lecture, or based on the previous concept that I have explained earlier, I am going to explain this theorem number 6. But before this explanation, I'm going to show you a little bit construction, because we are going to do some construction here. What we are going to do, construct, draw AD is a line segment, which is a basically bisector. Okay, what you have to do, you have to draw this AD, right? How? Look at here. Just suppose this is your triangle. Okay, this is your triangle. As you can see, this is your triangle A, B. 1 minute. This is your triangle A. Okay, this is angle A, then this is angle B, and this is angle C. Okay, so in this triangle, you have three angles A, B, C. What you will do, you will construct, or you will draw a bisector from point A. Okay, you will construct a bisector from point A in such a way that it will meet at point at the line BC. So this is the line BC. Okay, and which point it will meet? They will meet at point D. Okay, so after that, what you will see, that this angle A will be divided into two angles. This will become 1 and this will become angle 2. Since you are going to draw a bisector, so angle 1 will be equals to angle 2. Okay, so what is our construction? I'm going to explain again. Just 1 minute. Okay, so what is your construction? This is construction. What you draw, you will draw a bisector AD that will meet at point at line BC. Okay, in such a way two angles, angle 1 and angle 2, will be congruent to each other. Okay, now we are going to start our theorem number 3, theorem number 6, and you have to prove it. Now look at here. What is your statement here? In triangle ADB. Now, where is triangle ADB? So, where is triangle ADB? Here it is. This is triangle ADB. Okay, ADB. This is triangle A, D, and B. This is first triangle, and this triangle is corresponding to triangle ADC. This is triangle AD and C. Okay, so you have two triangles, and these triangles are corresponding to each other. Okay, if you know about the corresponding triangle, so you know that the sides will also congruent. So which sides are congruent? AB is congruent to AC. This is side AB. Okay, and this is side AC. This AB basically is congruent to AC, and this is given to you. Okay, and also what you have constructed, that angle 1, this is angle 1, angle 1 will also congruent to angle 2. This is our construction. And AD is congruent to AD. Why AD is congruent to AD? Because as you can see here, this AD is a common line, or you can say the common side of triangle ADB and triangle ADC. Okay, so AD basically is a common side. Okay, that's why we are writing here common, or you can say identity congruence. Understand? So what is your statement? In triangle ADB, which is corresponding to triangle ADC, side AB is congruent to AC. This is side AB, and this side AB is congruent to side AC. This is given to you. Then angle 1 will be congruent to angle 2. That was your construction. And the side AD, which is side AD, this is side AD, is congruent to side AD. Why congruent? Because it is common between these two corresponding angles. Okay, now move on to the statement number 2. Now in statement number 2, what you have, therefore triangle ABD. Okay, now where is triangle ABD? Triangle ABD, here you have triangle A, B and D corresponding to triangle ADC. Previously what you were saying that ADB and ADC were corresponding, but now you are saying that ADB and ADC are congruents as well. Why they are congruent? Because according to side angle side postulate. Okay, now what is side angle side postulate? Look at here. I'm going to explain again. Side angle. Now this is the side. Okay, this is side BA. Okay, then angle A. Okay, BA. Okay, this is angle A, and then side AD. Okay, so side angle side and congruent to ADC. So ADC, this is your ADC. Now which side is congruent here? This AC. Okay, AC side, this angle 2 side AD. So side angle side are congruent. So you will say that triangle ABD congruent to triangle ADC, because according to side angle side postulate, if the side angle side of one triangle is congruent to side angle side of another triangle, so the given two triangles are congruent to each other. Okay, and if the triangles are congruent, okay, if the triangles are congruent, if I'm repeating again, if the triangles are congruent, so their angles, their sides and their vertex are also congruent. Okay, so what you have said that this ABD and triangle and this triangle ADC are congruent, so that's why their angle will also congruent. So at the end you will say that therefore measurement of angle B, this is your angle B. Okay, measurement of angle B will be equals to measurement of angle C by the congruence of triangles. By the congruence of triangle, what you have learned previously, that if two triangles are congruent, so their angles are also congruent. So what you can see here, that these two different triangles are congruent to each other. First they were corresponding triangle, then they are also congruent triangles. So if they are congruent triangles, so their angles will also congruent. So angle B will be congruent to angle C. So we have proved it here that angle B is equals to angle C. So that's the end of the lecture. I'm going to end the lecture here, and we are going to start our question answer session here. So what is your question answer session here? A dash is figure bounded by three straight lines. Please give me the answer. A dash is figure bounded by three straight lines. So if any figure that is bounded by three straight lines, so that figure is called as a triangle. Okay, that particular figure will be called a triangle. Okay, next is two triangles. Okay, how many triangles? Two triangles are said to be congruent. Okay, repeating again, two triangles. How many triangles are there? Two triangles, and they are said to be congruent if, when you will say that they are congruent, if their corresponding angles and sides are dash. Means what should be their corresponding angles and sides are they congruent, are they unequal, are they perpendicular or parallel? When you will say that the two triangles are congruent, when you will say that. Okay, so you will say that when their corresponding angles and sides are also congruent. So if two triangles are said to be congruent, if their corresponding angles and sides are also congruent. Okay. Now, symbol dash is symbol this one. This symbol is used for dash. Please give me the answer. This symbol is used for dash. Write down the answer here. The symbol this is used for dash. Yes, the correct answer is correspondence. Okay, this symbol is used for the correspondence. Okay, next, triangles has 6 elements. Out of those 6 elements, dash, angles and dash are sides. So how many sides and how many angles are there in a triangle? Yes, the answer is what? Triangles has 6 elements, out of which 3 are angles and 3 are sides. Okay, 3 are angles and 3 are sides. If two sides of a triangle are congruent, the angle opposite to them are also dash. If two sides of a triangle means if you have any two sides of a triangle that is congruent, so what you will say, the angle opposite to them are also what? Yes, or also congruent. I'm going to write it here, trying to write down. So you will say that the answer will be congruent. Okay, the answer of blank number 1 is triangle. Okay, two triangles are said to be congruent if their corresponding angles are and sides are congruent. So the answer of this one will be congruent. Okay, and this symbol is used for correspondence. Okay, this symbol is used for correspondence, right? Correspondence. Clear? So this is the end of the lecture. If you want to ask anything, if you have any questions, so you can ask, you can write it down in the comment section. Okay, so I'm going to end the lecture here. So but before ending the lecture, I would want to tell you that you have to copy down the theorem in your geometry copy and draw all the figures in front of the theorem but with pencils. Okay, but before starting theorem number 6, you have to make the title page of theorem number 6 again. Understand? So this is the end of the lecture. I'm going to end my lecture here, and please take care. Allah Hafiz.